Alright, yeah, welcome back again. Okay, this time I want to look at LDA. LDA means linear discriminant analysis. The LDA is a very powerful tool in past. Of course, you must understand that LDA is one of a supervised learning algorithm. Okay, LDA is not just to classify the subject into different groups using the scatter plot, not just for discrimination purpose only, but at the same time, it shows the accuracy of the classification in past. You can see the accuracy at the same time using a jackknife algorithm. So here we are going to look at how to classify this our data using LDA, linear discriminant analysis. All right, so as usual, we are using our PCA data, so which we have collected. We are not going to use all the PCA data actually because none of them are useful. So you can base it on those who accrue to 95% or 100% variation. Okay, so you can do that, but I just want to use a try an error approach. Try an error approach here so that you can see the difference between the two. So here, what I just want to do here now, I've just select this. Anyone you want to number of pieces you want to use. You may not need all the pieces actually, because if you look at it properly, PC towards 11, I mean towards here, there are zeros. All these ones, they are not useful. So you may need PC to 40, but you may delete all these ones. If you don't want them, you can delete them. You just need few one, but you just look at the piece that they give you higher values of a jackknife. Okay, I'm going to differentiate between the two. So if I select now, I already use my faces now this time around, so I'm sure you have to do that, so that was not a problem. So I want to use the faces of the individual. So I select, I order my control key, I select each of them. I select and I click it to select more, select each of them. So I'm trying to let me first do let me do 15 first and see. Click on multivariate, ordination, and LDA. So click on LDA here. You can see here, see the scatter plot. Can you see that now we can now see the proper distribution of this now? All right, so let me increase it a little bit. You can see here the separation of the using LDA. Look at the Europeans, look at the Asian, look at the Africa separated here, and let's look at Morphometrics now. Here we have 93%. This 30%, this particular one is not actually very accurate, so you cannot don't depend on this. So click on this jackknife. This one is the best one to use. Okay, click here. Can you see now that changed to 88%, 88.3%? Before it was what, 99, 93. So this is accurate. This one is more accurate. All right, this one is actually cross validation method, this jackknife. Okay, all right, so that is what you'll be using. Just leave it like that. So you can now see that this total here, row wise, total column wise. Okay, you can see here. So you can find your accuracy also manually by using you can this go down here. And so you can also find more, or if you want to find more of a value, maybe other matrix, other metrics, you can find them. If you want to find them by using manual method, you can calculate them. Okay, so that should not be a problem for you if you want to do that. So this is centroid here, SS1 and 2, and we have classifier here. Okay, so this is loading this score. All right, but you don't need to actually, you only need this. Okay, and this. All right, so but let's do more. Let's try to see if you can get more value apart from this 88.3%. Okay, I think that is highest for jackknife. I think so. So, but you can do a trial and error by selecting more or less and see the difference. So let's select more till, well, at a point it will not, the value will not increase anymore. I mean the accuracy will not increase at a particular point. It will stop increasing. Okay, let's say at 20. Let's say at 20 now. Let's try at 20. Let's see what we get. So in case the separation has changed. Okay, so now what do you have here? Jackknife 90. You have 90% for jackknife now. Okay, this one give you 98%. Can you see? For jackknife, this you can have 100% actually, but jackknife cannot have 100% of jackknife. Okay, so this one is 90%. So 90% is very high. Okay, which is good enough. So, but let's see if you can have more. If I can have more higher accuracy using 30. Remember, we have 90% for jackknife. So take note of that. So let's say we solve at 30. What do you have? Right. 81. Can we see that's come back to 81? So at a point, it will stop going up and start coming down again. So but the point at which is highest is what you choose. And think 90 is highest. So you can play around that area and see that around 90, where you got 90, you can just add one or remove one and see the improvement. If it is improves or if it is this is a number. So that is how you get the better accuracy. So using jackknife. So don't use this one. Okay, use jackknife. I think that will be more accurate for you. This is a cross validation actually. All right. So you can copy this and paste in your Excel. So this is a good result. Just paste here. All right. So you can find the total here, total here. So you can find your. If you sum this one together, you can actually do it manually. Okay. Of course, this one can this is a row. This one from here. This one can sum it together, and the total number of this over everything. So it's very easy to calculate it manually. Okay. So you can also calculate other parameters. I mean other metrics if you want to. Okay. So that is just it is just accuracy only. Accuracy only. So if you want to calculate precision, the other one you can do that as well. Okay. So that is just how to get the LDA, and the most importantly, the plot is very clearly separated. Can you see here? Separated clearly. You can increase the size if you want to 4, make it more bigger. All right, all right. You can increase the size. I see here. So I see here. So you want to use a 95% increases. Okay. You want to use Confess or it's okay. You can use. Okay. So you can see. So that is that about this. So I think this is very good. You can use this one in your experiment analysis. You don't want to use scatter plot. If you want to use a scatter plot, any shape or symbol you want to use is allowed. You can use it in a pass as well, which I have shown you before. So now you can use this also as well. So thank you for listening. I will see us in the next time. Bye for now.